Hi, and welcome back to my channel, The Opinionated Science Educator. When I was teaching, I was appointed by the Department of Education on an ad hoc basis to mark the physical science papers for 3 consecutive years. So marking the papers gives you a good indication of the types of errors that students often make. Now, one of them is units. Students forget to put units, or they put the incorrect units. So today's support lesson is looking at the importance of knowing what the different units are and, when doing calculations, to include units. Let's first look at what we mean by quantities in physical science. In science, we measure physical quantities, and we can use these to calculate or find other physical quantities. And all physical quantities can be described as either a scalar quantity or a vector quantity. And in part 2 of this video, we will look at how scalar and vector quantities differ. But for now, we will focus on what is meant by a quantity. So physical quantities, what do we mean? Here are some useful definitions. A quantity in the general sense is a property ascribed to a phenomena that we can see, or a body or a substance, and it can be quantified or given a number. And so we can assign these numbers to particular phenomena. So for example, here is a gold bar. That gold bar has a mass. I'm ascribing a quantity to that gold bar. It has a mass. Here is a capacitor. I'm ascribing a particular quantity to that capacitor. It can store charge. I can put a number to how much charge is stored on that capacitor. Now, in a more particular sense, a quantity is quantifiable or assignable, and can be assigned to a particular phenomena or body or substance. So, for example, the moon. The moon has a mass. A proton has an electric charge. I can give the mass of the moon a number. For example, there it is. And the proton also has a mass, but it's much, much smaller. So I'm ascribing a number, and I'm saying what that quantity of the mass is for the moon and a proton. And for the proton, I can also assign an electrical charge. It has a positive electrical charge of 1.67 times 10 to the minus 19 coulombs. So I've assigned quantities to these particular objects. Now, a physical quantity can be used in mathematical equations that we have in science and technology. For example, density is the mass per unit volume. I can use the mass of the gold that I have in kilograms and the volume of the gold bar that I have in meters cubed, and I can do a calculation and I can find the density of the gold. Now, a physical quantity also has a unit, and that unit is defined and adopted by convention with other particular quantities of the same kind, so we can compare and express their values. Now, what do I mean by that? Okay, there is a gold bar. It has a mass of 1 kilogram. Let's say I take that as my standard. I have a silver bar which has half the mass of the gold bar, and a steel or cast iron ball that has a mass of 5 times the gold bar, so it has a mass of 5 kilograms. So comparing it to the gold bar, the silver bar has less mass, the cast iron ball has a greater mass. Now, if I use the gold bar as the standard for my strength and being able to lift things above my head, I know that I could lift the silver bar much easier because it has less mass, but I would have more difficulty lifting the cast iron ball above my head. So the gold bar is the standard by which I measure my ability to hold something over my head. Now, using my strength as in relation to being able to lift the gold bar and comparing the others is not a good standard, because a strong man or someone who won the world weightlifting champion will be able to hold be able to hold a cast iron ball over his head for much longer than I can, because he has greater strength. Therefore, as a standard, it's better to use a standard that is adopted internationally, and we will talk about that in part 2 of this video. Then, the value of a physical quantity is a quantitative expression. In other words, an algebraic expression of a particular physical quantity. And that is, the expression is the product of the number, the numerical value, and its unit, or the algebraic expression. So, like I said, let's think algebra. In that algebraic term, 4n squared. Okay, that is the term. The 4 is the number at the front. It's called the coefficient. The n is the letter part. It is called the pronumeral. So 4, if the n was 2, 4 times 2 is 8. If n was 4, 4 times 4 is 16. Then there might be an index or a power for that term. So let's think of the gold bar. It has a mass of 1,000 grams. The 1,000 is the coefficient, and I multiply it by G, which is the pronumeral. It's in grams. That could be kilograms, so it's important to have that pronumeral. And there the volume has the coefficient, the pronumeral, and a power, because it's length times breadth times height. Meters times meters times meters is meters cubed. So let's think of the quantities we express as an algebraic term with a coefficient and a pronumeral, which is the unit. That is very important. Joey's phone rings. Joey jumps up with excitement. A job, hooray! So he runs over to pick up 1 gold. And he thinks that's an easy job. Wait, that's not 1 gold. That's a pile. Units, units. So not 1 bar, which has a mass of 1 kilogram. 1 ton of gold.